All right, guys, this should be the third and final video for the week. I want to start off, we have a theorem that we have to take a look at, and it has a specific word, subtend, which is pretty commonplace for most geometry textbooks, but probably a word that you haven't seen before. So really the word subtend, the easiest way to remember that is it means, okay, to go, how about go, G-O-E? How about go across? That's really what it means. Okay, for lack of a better phrase. Okay, so we can have certain objects geometrically subtend other objects. And we usually see this word subtend within the context of central angles, inscribed angles, and circles. Okay, so for instance, in this diagram, okay, if we look at segment AB, okay, right here, notice that it goes all the way across angle ADB. Okay, so you have an angle ADB, which is an inscribed angle, okay, because the vertex lies on the circle, and we have this segment AB, which obviously is a chord, and it subtends that inscribed angle because it goes all the way across the angle from one point where the angle intersects the circle to the other point where the angle intersects the circle. So we could have a chord or a segment subtending an angle. We could also say that an angle subtends a segment. Okay, so if we look at angle ABD, another inscribed angle, angle ABD, notice that it would subtend this diameter, AD, okay, because the angle goes all the way across the segment, which happens to be a diameter, from one point where the diameter intersects the circle to the other point where the diameter intersects the circle. So we could have a segment or a chord subtending an angle. We could have an angle subtending a segment, which could be a diameter, it could be a chord, doesn't make any difference. And then we could also talk about subtending, okay, with arcs as well. Okay, we say that arc AB right here, okay, subtends, notice this is a central angle, angle ACB, okay, because once again the arc goes all the way across the angle, okay, from one point where the angle intercepts the circle to the other point where the angle intercepts the circle. Okay, so this notion of subtending, it just basically means to go across, and it's usually used for this sort of situation where you're dealing with inscribed angles, central angles, circles, and obviously that would involve certain segments and certain arcs as well. Okay, it's just a terminology, that's all it is. Okay, so we get this theorem, which your book calls a corollary. Okay, remember corollaries are just theorems that result directly from other theorems. Okay, so if we have two or more inscribed angles, notice it has to be plural, okay, in the same circle, and they are subtended by the same arc or chord, then the angles have to be congruent. Okay, so for instance, if we look at this diagram here on the left, notice I have angle ADB right here. Notice that angle is right in here. Okay, and I also have angle AEB, AEB. That angle's right in here. And so if we take a look at each of these angles individually, you'll notice that they are subtended by the same arc. Okay, so if we look at angle ADB, notice the arc that subtends it, okay, is arc AB. Okay, and if we look at inscribed angle AEB, notice that once again it is subtended by arc AB. Okay, so for instance, let's suppose that arc AB measured 80 degrees. Well, we know that an inscribed angle is always half the measure, okay, of its intercepted arc. So inscribed angle ADB would have to be half of 80, so that would have to be 40 degrees. And inscribed angle AEB would also have to be half of 80, so that would be 40 degrees as well. So we have two inscribed angles that are both subtended by the same arc. That means they have to be congruent. Okay, it also works if you have angles being subtended by the same segment. Okay, so for instance, okay, if we have angle SPT, okay, which again is an inscribed angle, angle SPT right here. And then we have angle SRT, okay, which again is an inscribed angle, angle SRT. We have that guy right there. Now notice that this inscribed angle, SPT, is subtended by this segment, which is a chord, okay, segment ST. And then we take SRT, okay, inscribed angle SRT. Notice that it is also subtended by the same segment or chord. Well, notice that if both of these angles are subtended by the same segment or chord, that means they are also subtended by the exact same arc. Okay, so if we have two inscribed angles subtended by the same segment or chord, that means they're also subtended by the same arc, which means they have to be congruent. Okay, so for instance, okay, if this, let's make it, I don't know, 74 degrees. So if that arc is 74 degrees, and notice that that arc is subtended by this segment, which is a chord, and both of these angles, which are both inscribed, are subtended by the chord and therefore the arc. Both of these angles have to be half of the measure of the intercepted arc. Okay, so half of 74 is 37, so that has to be 37 and that has to be 37, and clearly those two inscribed angles have to be congruent. Okay, so pretty easy to work with, not a hard one. Okay, so we take a look at this. It wants us to find the measure of angle ABC, ABC, right in here. It wants us to find this measure right here. It wants us to find the measure of ADC, ADC, okay, right here. And it also wants us to find the measure of arc AC, right here. Okay. All right, so let's see. First things first, notice that angle ABC is an inscribed angle because the vertex is on the circle. Angle ADC, ADC is another inscribed angle because its vertex is on the circle. And notice that both of those two angles are subtended by the same arc. Okay, so that means these two angles have to be congruent. So we can set these two expressions equal to each other and solve for x. Okay, so we get 7x minus 11 equals 5x plus 9, and then we just solve that. So subtract 5x from both sides gives us 2x, add 11 to both sides, so that gives us 20, divide by 2, so obviously we get x equal 10. Okay, so it wants us to go back and find these two measures. They better be the same or we're in trouble. Okay, so let's see if we go 7 times 10 minus 11, well, that'd be 70 minus 11, which gives us 59 pesos. Okay, and then if we go 5 times 10 plus 9, well, that's 50 plus 9, so again, that's 59 pesos, which we expected. Okay, so we know the measure of angle ABC is 59 pesos. We know the measure of angle ADC is 59 pesos, but we still have to come up with the measure of arc AC. So this goes back to some things we were talking about yesterday and the day before. Okay, so we know that the measure of an inscribed angle is half the measure of the arc. Okay, so that would mean that the measure of angle ABC has to be half the measure of the intercepted arc, which is AC. Okay, another way of saying that is 2 times the measure of angle ABC is equal to the measure of the intercepted arc. Okay, well, we know the measure of the angle. Okay, the measure of angle ABC is 59 degrees, and notice you could have used angle ADC for that matter. It doesn't make any difference. Okay, so the measure of arc AC has to be 2 times 59 pesos, which gives us 118 pesos. Okay, so this arc right here is 118 pesos. Pretty straightforward problem. Not hard whatsoever to do. Okay, let's see. Similar type situation. Okay, let's take a look at angle ABC. ABC, again, another inscribed angle, okay, because the vertex is on the circle. And then if we look at angle ADC, again, another inscribed angle. And notice that those two angles are subtended by the exact same segment, okay, segment AC. Okay, so if two inscribed angles are subtended by the same segment, then they have to be congruent. Okay, so that means that this guy right here, angle ABC, has to have the same measure as this guy here, angle ADC. So again, set these two expressions equal to each other. 8x plus 1 equals 4x plus 21, and solve that guy. So subtract 4x from both sides to give us 4x, subtract 1 from both sides to give us 20, divide by 4. So if we did it correctly, x should be 5. Okay, so we got to go back and we got to find these two angle measures. Okay, so just substitute in. So this would be 8 times 5 plus 1, which obviously gives us 41 pesos. And then here we would go 4 times 5 plus 21, which would give us 20 plus 21. So again, that's 41 pesos. So we should feel pretty good about x being 5. So that guy is 41 pesos. This guy is 41 pesos. Okay, now it wants the measure of arc AC. So again, we can use either inscribed angles to find this. Doesn't make any difference. Okay, so we know from the previous days, we know the measure of any inscribed angle, angle ABC, is half the measure of the intercepted arc. Okay, so I could say the measure of angle ABC has to be half the measure of the intercepted arc, AC. Okay, another way of saying that is 2 times the measure of angle ABC, the inscribed angle, is equal to the measure of the intercepted arc. Okay, and we already know the measure of the inscribed angle is 41. So we can say the measure of arc AC is just 2 times the 41 pesos. So we get 82 pesos. Okay, so this guy is 82 pesos, and we are good to go. And that should be enough to get you going on that quiz, which is due next Monday, I think. Okay, you can check on Classroom. I'm pretty sure it's Monday. Now I'll leave you a note about that. Number one, you want to make sure you get it turned in on time. You don't want it to be a late, or it's not going to give, or I'm not going to give you full credit for it. And secondly, it will be graded just like a quiz. It's not like homework where you get credit, no credit. This will be a grade, so make sure you do your best on it. You guys stay safe, and I'll be talking to you soon.